Bismillahirrahmanirrahim. Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's topic of discussion is nomenclature of heterocycles, in which we will discuss that what is the heterocyclic chemistry, then a brief introduction of the heterocycles, followed by their rules or rules for nomenclature of the heterocycles, focusing on a series of examples. So let's start. First of all, the heterocyclic chemistry is the branch of organic chemistry dealing with the synthesis, structure, properties and applications of the heterocycles. That means in this branch of chemistry we will study that how they are synthesized, what type of structure they retain, and what type of properties and applications they have. Then there comes that this is actually based on the heterocycles. So what are the heterocycles? What type of compound these are? Actually, any ring structure or a cyclic compound having atoms of more than one atom or more than one element as member of the ring. For example, that is a cyclic structure, that is a closed one, a cyclic compound having atoms of more than one element. Here there are only carbon and hydrogen. So in addition to carbon and hydrogen, the atom of any other element other than carbon and hydrogen, for example nitrogen or oxygen, sulfur, phosphorus, right? So the cyclic compound having atoms of more than one element as a member of its ring, that would be called as heterocycles or heterocyclic compounds. And they may be either saturated or unsaturated. If it is unsaturated one, then its name would be pyridine. And this heterocycle contains nitrogen. So such cyclic compounds having elements other than carbon and hydrogen as member of their ring, so these would be called as heterocycles. For example, pyridine, here that is furan, and similarly that is thiophene. Here it is thiophene and it is furan. So now we step forward to the rules of the nomenclature. There are three different ways of nomenclature of heterocycles, that are Hans-Widman nomenclature, common names, and replacement nomenclature. First of all, we will discuss this Hans-Widman nomenclature. And according to this nomenclature, there are a set of rules according to which we name any heterocycle. According to this nomenclature, for example, there is a general structure or generally representing the heterocycle. This is Z, CH2 and CH2. Any one CH2 group may be represented with the value of N. And here the value of N varies from 1, 2, 3. This N shows the number of the methylene groups. because it is in the ring structure here, that is CH2, and two other bonds are being here with this Z that shows the heteroatom and with the other carbon. So here this CH2 group may vary from 1 to onward, and this Z represents the nature of the heteroatom. For example, it may be either oxygen, nitrogen, sulfur and phosphorus. That is nitrogen, oxygen, sulfur and phosphorus. And this, when we write down the name of the heterocycle, then this heteroatom comes as a prefix. Then shortly, this value of the N represents ring size as well as nature of the ring. For example, if here that is CH2, it would be saturated in nature, and if that is just CH, that would be forming a double bond or unsaturated character. So the ring may be either saturated or unsaturated, and that would be represented with the value of the N. So the N would indicate the ring size and nature of the ring. So after the prefix, we will write down this notation. That would be in the stem, prefix, stem, and sometimes it may contain any ending name and sometimes it is not been necessary. So depending on the heterocycles, this one may be optional. Prefix, stem and ending, or generally prefix or stem. This is the general setup for the nomenclature of any heterocycle. Now we move towards the nomenclature according to the different heteroatoms. If the nature of the heteroatom is written here, and what prefix would be used, that is over here. If the nature of the heteroatom is nitrogen, then a prefix that would be used is aza, and if that is oxygen, then oxa. For sulfur, it is thia, and for phosphorus, this is phospha. So these prefixes would be specific for these heteroatoms. And now, based on the ring size, what suffix or the stem name would be here? Actually, a stem is almost equal to the suffix plus any specific or saturated or unsaturated character. So the stem depends upon the suffix plus saturated or unsaturated character of the ring. So here the suffix would indicate the ring size, and the saturated or unsaturated character would be followed by this. For example, if the ring is 3-membered, 4, 5, 6, 7, 8, 9 and 10-membered, then the appropriate suffixes would be air, that would that would be in between the prefix and the saturated or unsaturated behavior or the ending name. And this saturated or unsaturated character actually means the ending, where we had said that there would be a prefix and stem, then that was actually the prefix, suffix and ending. Here, for the three-membered ring, the appropriate suffix would be ir, ir. For four-membered, that would be it. And these have been derived from tri, tetra. Then for five-membered, that is for all. For six-membered, that is in. For seven-membered, that is ep. For eight-membered, that is ok. For nine-membered, that is on. This is from hepta, then octa, and from nona, and from deca, that is ec. So in this way, we use these suffixes to highlight the ring size. Now we see that how the saturated or unsaturated behavior affects the name of these heterocycles that are based on these different heteroatoms. Here we indicate the ring size, then here that shows the saturated system with either oxygen or sulfur, and here that is for nitrogen, based on oxygen, based on sulfur and saturated with nitrogen. And then there comes the unsaturated system. So if that is three-membered ring, so in the case of oxygen, it would look like this. In the case of sulfur, it is like this, and in the case of nitrogen, it would be followed with one hydrogen over here. In the case of saturated ones, the nomenclature for nitrogen is a bit different, but in the case of unsaturated, it follows the same as in the case of oxygen and sulfur. For the saturated, we use ANE as the ending, and prefix would be used as oxa. Then for three-membered ring, we had used ir plus in. This is prefix and this is the stem, where this shows the ring size and this would show the saturated or unsaturated behavior of the ring, that is nature of the ring. So these three words would be followed up as a single name, as here the A would be replaced and the proper name would be oxy rain. And similarly thia, ir, in. In the case of thai, iran, here this thai A has been omitted. So when we combine all of these letters, then it comes to be thai, ir, in, thyrane. But in the case of nitrogen, that is prefix is aza, ir, and the saturated ring would be followed up with the idene. So the complete name would be here, the A would be omitted and then the complete name would become aziridine. And in the case of unsaturated behavior, for three-membered we use irene, That is the unsaturated character in the case of three-membered ring. Here, in the case of oxygen, in the case of sulfur, and in the case of nitrogen. So in the case of oxygen, that is, here it is oxa, then rin plus irene. So that indicates that here this A would be omitted and its complete name would become oxyrene. And similarly for sulfur, this would be thyrene. And in the case of nitrogen, that would be azirene. So in this way, for the three-membered ring, different heteroatoms would be given different names, but according to this set of rules.